Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. I'm Farah Amirah binti Azmi, represent my team from University Malaysia Terengganu to present our project entitled Cinnamic acid analogues potential antibacterial agent. Let's start with our introduction. First of all, what is bacteria? Bacteria is a single-cell organism that thrives in diverse environments. They can live almost everywhere in the earth, including in soil, ocean, and even human gut. Actually, there is a good and bad bacteria. For example, a good bacteria can help with our digestion system. They also can convert milk into a yogurt. Meanwhile, for bad bacteria, they give us infections that is dangerous for our body. Bacterial infections are caused by harmful strains of bacteria on or inside the body. They can affect any area of the body, including our skin. They can cause from simple to severe infections such as acne, food poisoning, pneumonia, and many more other infections. Next, current problems. First, some bacteria are immune to the existing drugs, which make the treatment become harder and ineffective. Second, the development of antibiotic-resistant strains are increasing day by day due to the misuse and overconsumption of antibiotic drugs. For example, S. aureus resistant to the penicillin and ampicillin, E. coli resistant to the fluoroquinolones. According to the World Health Organization, antibiotic resistance become one of the biggest threats to the global health, food security, and even for the development today, especially to the developing and low-income countries. Why we choose cinnamic acid molecules as our main material? First, they only need a simple step preparation. Second, they have been proven from many researchers to have remarkable biological activities, including antibacterial, antioxidant, anti-cancer, and many more. Third, research on these molecules are secret, especially for octocameric acid. And the last one, new structural modification to enhance biological activities. Move on to the novelty or inventiveness. Gladly, our synthesis cinnamic acid analog are firstly reported as antibacterial agent. Next, for our method, first we synthesize the reaction. After the completion, the sample undergo rotary evaporation before proceed to the column chromatography process. And lastly, the sample were tested for their antibacterial activity using this diffusion method. As for results, inhibition zone were measured for the antibacterial activity. In our project, we use 3 different gram-positive bacteria test strains and 2 different gram-negative bacteria test strains. As you can see, almost all of our compound can inhibit the bacteria growth for both gram-positive and gram-negative bacteria. Our compound show the best activity against Pseudomonas aeruginosa strains compared to the others. For your information, World Health Organization has published a list of 12 bacteria which pose the greatest threat to the human health because they are resistant to the antibiotics. And Pseudomonas aeruginosa are one of the bacteria that are considered to have critical priority for the development of antibiotic drugs. So, our project show a good sign to lead a new development of antibiotic drugs specifically for Pseudomonas aeruginosa. Okay, let's move to the contribution to nation. First, our project lead to the development of new antibiotic drugs which are needed nowadays. Second, our project can provide scientific reference for the future research. For future prospect, our product has potential to be new antibacterial agents specifically for Pseudomonas aeruginosa strains. Academic recognition, publication, 1 published paper, human capital, 1 PhD student, 3 master students are ongoing. Bronze medal on MPI 2020. Lastly, special thanks to Ministry of Higher Education Malaysia for the FRGS, and also thanks to the Faculty of Science and Marine Environment UMT for providing research facilities. That's all from us. Thank you for watching our video.